All right, Cláudio, nearly good to go. Take it away, please.
Yeah. Okay. Thank you, Andrew. Thank you, 8KB, for another year and another online conference where we can try to share some more in-depth info. And today, I will bring some X-raying schema operations, adding and removing columns. As some other sessions that I usually do, these appears related with some client questions, and then my curiosity, and go after some stuff and going on the rabbit hole and get a bunch of demos, and then like to share and to spread the word with the others. So, but before we go, because this will be a demo session, it will be important to remind here what is a data page on SQL Server. And a data page is a 8 KB page. So we have 8,192 bytes. Each one of these page, as we can see here, as this representation from Paul Randall. If you never heard or read something from Paul Randall, I encourage you to go on the website and see all the golden things that is there. So a page can be divided in this case with the page header that always occupies 96 bytes, which means that it will leave 8,096 bytes for records. And very important is to remember that one record on a single page cannot have more than 8,060 bytes. Why is this important for something about adding and removing columns? We will see in a second. So my name is Cláudio Silva. Sorry, because the animations went over. And I work for Data Masterminds. My regular day-to-day is inside of SSMS and ADS and performance tuning ugly queries and try to make the things faster. When I'm not doing that, I'm doing some automation with PowerShell. I'm a proud open contributor of the open source projects DBA2 and DBHX. Yeah, and there is my contacts. I expect these demos will be uploaded for the 8KB GitHub, but you can also find it in my GitHub. So let's move to the interesting stuff. The first demo I want to give, let's start with adding columns. So adding a column was, and it is always a kind of online operation. What does that mean? It means that we can add a column and not blocking the entire table, because in this case, when allowing nulls, this is a kind of a metadata operation. So it's quite fast to be done. So for our demos, I will be using X-raying database. It's an empty database where I will be dropping and creating a table a bunch of times with different columns and different sizes and so on to show what I mean for each one. Here I'm running these demos on a Docker container. So I'm using a SQL 2022 on a Docker container. I have one enterprise and one standard because at some point we'll need to compare something. So let's start with creating a table where we have 3 columns, the ID, first name, and the date of birth. Then let's insert 50,000 records, and we can check that we have data there. So now let's see how much space this table right now occupies. And here we can see that we have our 50,000 records and how much is reserved, which is a sum between the data and the index, and how much is unused. So data pages that are allocated but not yet used. And to get rid of this unused space, just to tidy up the things in this specific case, let's do a rebuild. And if we check again, the 120 KBs, now it's 56 KBs. Now, this is an internal conference, right? And we will be using some undocumented comments, which I would say undocumented from Microsoft's perspective, but there is some kind of good documentation from other sources, people from the community, and even from like Paul Randall, people that probably wrote some of those comments. So the first undocumented comment that I want to share about is the DBCC int, which will list all the pages that are allocated to an index. So here we can see that we have 170 records, and the records here have some different page types, and what is the pointers from one page to the other, etc. Nowadays, or more recently, we also have a new DMF, a data management function, a dynamic management function that allow us to get some kind of the same results with a little bit more details and descriptions. But still, we can see here our page descriptions, and here we can see that we have 177 records. So this second comment is showing 7 more page or records in this case compared with the DBCC ints. So the difference here, just to explain, because depending on what you are doing, you may want to use one or the other, is to share that the DBCC int shows the 170 page, and this means 168 page that are the data that we have. And then we have 2 index pages. So when we see here the 2 index page, one being in this case the EAM page, and the other one is a page belonging to the cluster index. The 7 page that we see being more on the second result set, these ones are belonging to this data page that are not yet allocated, and therefore they still appear here because, or they are allocated, not being used, and therefore we have 7 page times 8 KBs will be the 56 KBs that we saw before on the SP space used. Now, another 2 comments, one maybe more known for more people, which is the trace one. So is the comment that we can use to enable trace flags on SQL Server. This trace flag 3604 will be so we can dump a data page from SQL Server to our message console instead of going to the error log. So we'll need to turn this on, and then we will be using the DBCC page to show for a specific database what is, and picking one page ID, we will then print, and in this case I'm using the option 3, which means that we'll get the page header and then also details per row. So let me pick here one data page, and let's see what we can see here. So this is a data page, and with this option we get a buffer part of it, and then as we saw before, we have a page header, the one that occupies the 96 bytes, and then we have the information per record. So we can see that we have a primary record with a record size of 25 bytes, and then our values are here. Okay, so let me pick this because the past Cláudio said to copy paste this to a new window. And now let's see what happens when we add the new column. And this is a column, job title, varchar 50, and allow nulls. So adding this column is just quick, right? And if we see, the column appears here with the null value. So what happens? What happened in the end when we add this new page? So if we pick again the data page, and let's put these side by side, so we can do a comparison on a couple of things. So one of the things that I want to show you is this MLSN value, which tell us what was the last logical sequence number that was written and that changed that page. And as you can see here, even that we had the column, this didn't change, which means that our page was not written. So the SQL Server doesn't have to go to each and every page, change the page to add the column and to add a null value, okay? So this is a proof in the end that this operation is a metadata operation instead of being a writing operation afterwards. So we can also see that if we check one of the records, and here the same, that here we had our 3 columns, and here now we have 4 columns where our job title appears with a null value. And the interesting part here also is that we don't have yet an offset on the page, meaning that we don't have a value. So again, this is some kind of metadata that SQL Server stores and knows where it is. And right now, because we don't have data written there, we have a length of 0, and also the physical length is 0. Now, how do we know, or how the engine knows, after all, that this column exists, and whenever someone does a select, it will need to show some extra columns. So the columns are already there, but for us, if we are seeing the data page, we don't see values there. So how the engine knows that? So enters a couple of system views, also undocument, which are called the system internal partitions and also system internal partitions columns. So I will join both here. We have a lot of data here. And I mean, because we don't have official documentation, we can only infer some of it. And we can see that how many rows were modified. My last column haven't modified yet any records, the data types, the max length, and a bunch of other values. So if we just pick a fewer columns just to make it easier to read, we can see here that for our index ID 1 and our partition 1, we have 4 columns which has these names, and these are the modification count, and we have the information if it is nullable or not, and what is the default value, which is in this case is null. So now let's do an update on our first record of the table, ID number 1, and let's say that the job title, is developer. And if we now pick the page and check again the differences, now this LSN changed. So before, if we pick one of those, it ended in 6841, and now it's already 22. And if we check here our records, we now have a proper or a value for the job title, and we can see that we have an offset, also a length of 9, because we have 9 characters there, and the physical length is also 9. So we saw the MLSN changed, and the actual value is also there. However, someone will say, well, but this was 50,000 records. These are very few number of pages. Doing that change, even more on the system that is not doing anything else, will be quick. Yeah, sure. So let's say that we had 1 million more records to our table. And then we will add again a new column. So right now we have 1,050,000 records. We have much more space being utilized. And if we check here and add another one, is still quick, very quick. So let's move to a second demo, which will be about adding columns that do not allow nulls. So they will have a default value, and we will see the implications of doing that. So the idea of this session is not only going to these internal parts, but also to correlate with real life challenge and scenarios, and give you more information that next time you need to deal with these situations, you can say, oh, wait a second, let's not go that way, let's do the other way, because I saw A, B, C. That can be a problem. So let's drop and create our client table, a table with 3 columns. Let's insert 50,000 records, and let's add the job title with not null and adding a constraint to say that we will have a default value of not defined. So do you think this will be fast, slow? It's fast, okay? And if we pick again on our list of columns, we see that we have the 4 of them, is not changed. And what we can see on our shorter version, now we can see that we have our job title that shows that we have this column has a default, and that default is not defined. This is on the metadata on these system views. So does that mean it is inside of our data page already or not? Let's have a look. So if I dump one page, I can check here that my column seems to have a value of MD, but take a look, doesn't have any offset. So this actually says that it's not written in the data page yet. Also, it knows that he has a length of 3, the 3 characters that we have here, but again, the length, the physical length has 0. So this, what it says is that the metadata is being used to populate and to give you the outcome whenever you just add a column and you said it's not null and have a default value. But I'm running here a developer edition, which is the same behavior as an enterprise edition. What can be the difference if we are on the standard edition? So do you think it will be the same? Let's see. So here I'm running another container with standard edition, okay? And I will create the same table with the same records and add also the job title column with the same definition, with the same constraint, with the same default value. And this is fast because no one is using, the table has a few data, but what are the difference on our metadata side? So here, we don't have information about having a default, neither which default value would be. So is this a bug? What is the problem here? Let's take a look inside of one of the pages to check what we can see there for this new column that we just had. So here, we can see that we have the column number 4, which currently has an offset, which has 3 bytes, it's here, and actually has also 3 physical bytes, meaning that our record was written on the page. So let's insert a little bit more records, another 5 million. So the main question here, or the main thing to retain, is that the main difference between the enterprise or a standard or lower version is that adding a not null column since 2012, SQL Server 2012, is again an online operation for the enterprise edition, meaning that only this metadata will be stored, and this can be a kind of instantaneous addition or an instantaneous run that will make possible to have the table functional and not like blocked because we need to write everything in every data page. So now with this, we have 5,050,000 records, around 150 megabytes. And let me drop the constraint, drop the column, and I will add it again. And I will run here the SPU is active to check with the get transaction info. So to check that when we do this addition, we will take some time to run. So we go with 6 seconds, and we can see that our transaction log is being written because our pages are being updated to be able to add this column, okay? So it finished for 5 million records. It took 10 seconds to update these 5 million records in order to add the job title column with the default not null. So be sure that you know this, because this will make as being an offline operation, meaning that your table will be locked and cannot be utilized by other sessions. And a different way of doing it, and also the way that we will do it in 2012, or even before 2012, and before, or not having enterprise or with enterprise 2, would be to add a column that allow nulls. You will need to do a bunch of controlled updates to update every row to your default value. And afterwards, you will be able to add a constraint. But at that point, because the data is already there, it will be a little bit more quicker than read and write every single page there. All right, so let's come back to our enterprise. And let's do the same test here about the 5 million records. So we saw it took 10 seconds to run on our standard edition. Let's go and add here our 5 million records for the enterprise edition. Let's see that we can see that exact data. And then we will drop and add again our column. So we have here our 5,050,000 records. Let's drop the constraint to drop the column. And now let's add our not null with the constraint and the default value of NB, and boom, it's done. So it took less than 1 second. Okay, so this shows this is kind of instantaneous, and this is the metadata operation. However, this doesn't work with all the defaults, okay? And this is on the documentation. The documentation is pretty good in these points. So what it says is that it will only work for a runtime constant, which is an expression that produces the same value at runtime for each row, even if it's not deterministic. So I mean, whenever we think about being deterministic, is something that we, for the same input, we get the same outputs. So just by that, I would not expect that a get UTC date would work, because if I run with a different input or in 2 different moments, it will receive 2 different outputs. However, it says that is a runtime constant. So let's see an example. If I add an update on a datetime 2 with precision of 3, and with the get update, the get UTC date, this will be instantaneous. If I do some default string like we did with the not defined, also instantaneous. And if we check one of our page, what we see is that we have our job title, which is still without an offset and without a physical length. Now we have also the update on and the update by. All of them were added through the metadata and not by writing every single page. So what happens if we try to add a unique identifier with the default of the new ID? So if we run this, now I can come back here, try to be quick enough to change to this one, and still get the session running for 12 seconds, because it's still writing data on our transaction log to register all the changes that is being done on every page of the table. And now it's done, and it took 24 seconds for this table. So if we check again here, what happened? So to add our unique identifier column, it actually had to write the value on the page with 16 bytes. And again, that proves that for these specific defaults, it's a no-go being online. So don't go and rush like, oh, I can add whatever I want as a default, because it won't write in my tables. So any questions so far, Jess?
Yes, we got a perfect question for this spot. And that is, are you aware of some comprehensive sources of information for what DDL operations are offline or online, and under which conditions, editions, etc.?
Excellent question. I don't think I ever saw like a short list or a summary of those. So if you compare like the features between standard enterprise, you will see some stuff like some stars to say, well, in this case, this is an online operation, or in this case, you can use not one single core, but multiple cores and stuff like that. I don't remember to see any specific summary table with the operations that are allowed to do, and the difference between standard enterprise and then we are using just our regular tables, disk-based tables. I don't know about in-memory tables and other stuff. But if anyone ever seen that before, I would love to get that and to have that short summary too, because more often than I would like, I find myself doing a small demo just to double check something before going and run somewhere else, because I don't know exactly the implications of it.
Yeah, totally. Cool. One more question for you. The metadata only operation with the not null column with the default value, is that just available with 2022?
No. Since 2012 and Enterprise Edition, this exists.
Perfect.
Okay.
Thank you.
So that is the one. No problem. Thank you. All right, let's move on. And we have seen how to add columns allowing nulls, and that is like online and not a writing operation for every page. We have seen how we can use Enterprise Edition to do that for since 2012 as being a metadata operation, and therefore with some caveats like which defaults we use can be an online operation. But what if I tell you that adding a null or not null column can update an entire table? Forget about what you just heard before, but this can happen in a very specific situation. But I think it's cool to be aware of it. So let's see. Let's create our table again. This one will have here a new column, which is the bio, and on purpose we'll have 7,992 characters, and it will be a char, meaning that even if I don't write anything, this will occupy 7,992 characters. And that is important for the point that I want to show. Now let's head here half a dozen of records, and let's see one page here. And what we can see here is that we have our record size is 8,042 bytes. We can see a bunch of data here for the char column. And on the bottom, we can see that we have our ID, our first name, our date of birth, job title, and our bio, which has this bunch of empty space. So now let's add another int. So an int column with a not null, default 0, and we are on the Enterprise Edition, okay? So if I add this, I have trouble. So it first says that the table client has been created, was created already, but still, and it exceeds the maximum size of the 8060 bytes that it can be. And then it says, be aware that insert of updates that will result in more than this length may fail. And we can see that it says cannot create a row with the size 8064, which is greater than the allowed maximum row size 860. So I warned about the 860 on the slide on the PowerPoint, but here it's saying that it cannot do these 4 extra bytes, which is the size of an int, right? It's 4 bytes. So let's take a look on one of the pages. So each record in this case is occupying is belonging to one page and just one page. So let's pick one of the bottom 3 pages and see what we have here. So before, on the other record, which was the first record and the first page of the table, it said that our record size was 8042, but here is 8060, which means is already the maximum value that you can have on a single record in one page. And this is for the hello, I'm Irene. And if I go to the bottom, what you can see here is that we have something new and some stuff. So we have an ID, and then we no longer have all the letters being repeated in the record, and now we have a different thing. We'll come back in a second. We have our date of birth, and also our job title is also different from as it was before. So let's say that I will delete the records with IDs 4, 5, and 6. And just to show the difference here is that the records that were inserted, these bottom 3, they insert 30 characters each, and the ones before just inserted 15, okay? So what happens if I delete these records that occupy 80, 60 bytes? The delete succeeds. And now what happens if I try to add the column again? It worked. I no longer have the red message. I still have the warning message saying to me, hey, be careful, because if you go crazy, you can surpass the 8060 characters, or bytes in this case, but no longer fail. So the column was added. And to prove that, let's see, I need to pick again one of the initial page. And this is hello, I'm Alex, meaning it's one of these first records. And if I scroll down to my data here, I can see that after my bio column, now I have another int. But we are on Enterprise Edition, and we are adding a constant value as a default of this column. And what can we see here is that we have an offset and we have a physical length, meaning that this had to be written on the page. So what happens here in the case? If the engine detects whenever you are adding a new column that you can surpass the value of the 8060, to be sure that that doesn't happen, it needs to go and update every single record on your table. If any of these records, by doing these updates, will fail because it surpassed the 80,060 bytes, then it fails as it failed before. So if it happens, abort, roll back. So if I try now to insert a record that exceeds the 80,060, I get an error saying again, cannot create a row with the size of 8064 because the maximal out size is 8060. Now, the question is, this can take some time to fail. And why? Imagine that I have 500,000 records. So I'm dropping and recreating or creating a table called fail slow. And I will show you that it can take some time to give the error saying that could not update. And while that is happening, because we are writing operations, the table will be locked. So no longer the metadata only operation. And therefore, this can create impact on your systems because they are running and someone else may need to access this table, and that will be locked. So with 500,000 records, we will see a new comment, dbcc show config. So this is documented, and this shows the fragmentation that an index of the data on the index or a specific table or view. If my inserts finish in the meantime, okay. It's taking longer than I was expecting.
I've got a question you can answer while that runs if you want. So back to the metadata, where is that stored as far as the defaults? We have a comment about adding a column with a default and then dropping the default, but the value stays on each record. So where is the metadata stored?
It's stored on that system. Let me pick it here. On this system internal partitions columns, that is the one that has the default value column. So cool. That is where the things are saved for the enterprise edition, because on the standard edition, as long as So for each version, even standard or enterprise, as long as you write on that table the value, so you persist that value on the data page, it will disappear from here from the metadata. If you just add the column like I did here and you check the metadata, it will appear saying you have this column with this default, which has a default, and the default is this value. Whenever it is a standard, this metadata will be always saying, yes, I have a default, but the default will be null because it's already persisted on the data page.
Perfect, cool. And kind of a related question to that is regarding availability group replication. If the changes are updating only metadata and not right into the transaction log, are they also being replicated to a secondary replica of the AG?
Yes, they will. So any operations and so whenever you create a table, whenever you change a table, those DDL operations are being replicated also for the secondary.
Perfect, thanks.
Thank you. So now it finished. It took a little bit longer than I was expecting. So let's see what this show config command showed to us. So it showed to us that we have this index, which is index ID 1, how many page I have, and in this case, how many rows. And as I said, on purpose, I'm putting a maximum of 1 row per page. And the important part here for now will be this data here. So the minimum record size, the maximum record size, and the average record size give us an idea that well, to the 8060, I still have 18 bytes that I can use, right? So now I will insert a record, another one. So I insert 500,000 with the replicate C and F 15 times, and now will be the I 30 times. This just runs okay. Let's check again our show config. So what changed here? And what changed here was our maximum record size. So by adding this new record, and instead of having the 15 lengths on these characters, I had 60 because I knew and I did the math, will give us the maximum record size that we can have. So what happens if I try to add another int to this table? Oh, it's running, cool. Oh, I will pick a coffee while this is running because it will take oh, wait, it's taking some time. And it's writing on my transaction log. Oh, but yeah, okay, I have on my maintenance window, no problem. So this will finish soon and I will be okay. Oh, already finished. Oops, it finished with an error. And it took 17 seconds in the end to be able to give an error. Why? Because that was the time it took to write all the previous 500,000 records, and then it reached the one that could not get these extra 4 bytes, and then it fails, roll back everything, and our table don't have our new column because of this. So how to solve things like this? Well, the first one will be not letting the user write an essay or like a big history about the bio. And of course, instead of having a char, you can have a variable length column. But of course, just to show here, if I create this table with 4 less bytes here, and I insert 50,000 records, so this will be a little bit quicker than the 500 before, then I can see the show config here, and I have 8056 as a maximum one, meaning that now if I try to add my integer column, it will succeed. And if I check the records, and now here a new thing to take into consideration, because it didn't surpass the value of the 8060 or could not surpass, it didn't write on every single page, meaning that the current page actually just have 8056 bytes. So be careful on relying on these outputs to say by default, I have enough space to add another X bytes, okay? So if we check our table and dump one of the page, so what we'll be able to see here is that our column was added, I have the default value, and again, no offset, no physical length, meaning in this case that was just the metadata operation and not a writing operation. And again, to show and probably to give some clarity to that last question, here you can see that we have another int, and it has 4 bytes. It has a default, and the default is 0. If we were on the standard edition, these here will be null because it was already written on the data page. But now, just to make the things a little bit more interesting, you may be confused about this. So if we sum the value of our max length, it will give us 8,059 bytes. So not 8,062, not 8,054 or 56 that we saw before. So what's happening? So what's happening is that the way that the size of one record is calculated, it isn't just the data types of the columns. There is a couple of extra partials that you need to use and to make it as an addition. So there is also documentation about that, how to estimate the size of a cluster index, of a non-cluster index, and even from a heap. And just doing here a quick math to help. We have a cluster index which is unique. In case it was non-unique, we need to add an extra byte in 2 of our variables for our calculation. Then we have a null bitmap. So null bitmap, this is again per record, meaning that depending on the number of columns that we have a null bitmap which will control the nullability of the columns in portions of 8 columns each. In this case, I have 5. 5 plus 7 will be 12. 12 divided by 8 will give 1 point something. 2 plus 1 point something will be 3. And the documentation says to discard the remainder, meaning that we have 3. So 3 bytes other than the size of all the columns. But then we have also the variable data size. So the columns that have variable length and how this is calculated is 2 bytes plus the number of columns times 2 plus the max variable size. So I had 2 columns with the varchar 30, meaning that I have 60. Doing this math, I have 66 bytes extra. And actually, there is an extra 4 bytes, which are a row header overhead that is present on every row. Meaning that other than the size that we have, the fixed and the variable, in this case, for this amount of columns, we have an extra 7 bytes of overhead. But if we sum all of this, our int plus our date plus our char and another int, plus our variable length, so this is 7,999, plus our 66 from the variable length, plus 3 plus 4, after all, I have 8072. So again, what's happening here? This is much more than 860, but it's working. So the thing is, when we have variable length columns, whenever that exceeds the 8060 bytes for the records, what the engine does is that it creates a 24-byte entry on the page and creates a pointer for a row overflow allocation. And on that allocation is where we will get our record, our variable length. So what happens in that case is that instead of having 66, we will have, instead of having 60 bytes, we'll have 24 times 2, which is 48, which plus the same 6 that we had here, it will give us 54. And now, if we replace the 66 by 54, we have the 8060 bytes here. And then if you want to know how much data, how many records can fit in one page, you can do also this calculation. So there is a value of 2, which is the entry for the slot array to say where the record is on the page. And in this case, for us, will be 1.004, so 1 record per page. Things important to take into consideration on these kind of calculations. It doesn't work that way with partitioning, with about the location page, the lob data, compression, and so on. So this is, let's say, the first simple example that I can give to show how the calculation is done. if any of these other things is involved, most probably you'll get to different values and values that does not match exactly what you would expect. So I mentioned row overflow data allocation, right? So if I go here and I pick one page, or I check what I have here, and I have here some page allocated. If I dump my page, now I will see again that I have these 2 pointers. So this is the first name is a column that has a length of 24 bytes. Why? Because he tracks whatever is inside by pointing this information or getting this information and pointing to a different page, okay, on the system. And here it just knows that it has 30 characters in this case, okay? So in this case, if I pick the one of the pages that are where it is, that are the page that are here, but from the, I need to go to the final ones. Sorry, here, yeah. You see that I have a row overflow data instead of having an in-row data. In-row data is the default, is when a record fits inside of the page. When we have these pointers that need to point to something else, in the end, what happens is that the engine creates a new page, which is of the type row overflow data, and inside is where we get that information. So if I pick one of these, just to show that inside, this page is a little bit different from the others, but here we can see that we have a record. This is the blob ID of the record, and this is the page, the in-row data page where the things are. So it will show, based on that, the pointer and show where it is. And then I know that I have 30 eyes in this case, and for another record, I have a different ones, and so on and so on. So this blob ID is the one that points to the allocation ID on the other page. Cool. Any question?
Not at the moment.
Oh, thanks. So then let's move forward to dropping columns and what that can show us. So what happens when we drop a column? What happens to the space that that column was occupying? It was occupying, is still occupying. Let's see. Let's create this table again, 3 columns. Let's insert here 50,000 records. Let's see that we have 1,440 KBs for the data, 1 index page and 4 page for the unused space. And here we have our page, and so far so good. What we'll see here is that we have our 3 columns with our values, everything is there. Cool. So there is, since 2019, a new DMV, or DMF in this case, is a function called the DMDB page info, which can show us the header of a page. So the same thing that we are seeing on the dump of the page on the header, here it also shows, in this case, in this kind of in grid format, and we can get the same kind of data that we were seeing on the other one. As an example, we have 279 records there, and we can also see that our last LSN was this one, like we saw before. So now let's see what happened when we drop a column. I've dropped a column, and I had 1,440 bytes, and I still have it. Everything is still the same. So what happened? What happened? Like, it's still the same as before. So let's pick and check what we can see inside of our page. So doing the dump of the page, what we can see here is that our third column, that was our date time, and in this case, we knew that was a date time, and we knew that it occupies 8 bytes, is still occupying physically the 8 bytes. But our column no longer has the column number 3. Now it has like this dummy ID, and it says dropped equal null. But our length, our record length, is still the 27 bytes as before. So what it shows is that dropping a column is not a writing operation per se, but rather a kind of metadata that says this column no longer exists on this table. So whenever you go and want to run again, because that column does not exist, it just shows the data that is inside of each page for the columns that actually exists. So as a curiosity, if this was related with deleting a record and not dropping a column, what happens is that you will see a ghost record on that page, and then the inserters that will, so when someone inserts data again, that will be overwritten and use that space. So those are the ones that will pay the bill in the end of the deletion operation. So this means to reclaim the space, I will need to rebuild my table. And then if I rebuild my table and I check the space, now I have only 1040 instead of 1400 bytes, okay? So seems easy. It's just to know that this is what happens, so metadata operation. However, be aware, because if you are expecting dropping a column, get space back, and if you, for that, you need to rebuild your table, be aware of, if you are on an enterprise or standard edition, rebuilding tables or indexes in this case, in enterprise edition can be online, but on standard edition won't be online. So it's an offline operation. So make sure that you take the right decision when you want to do these rebuilds, when you want to be able to actually recover and get back that space. So this is with rebuild. However, I have here another example about the DBCC clean table. So can the DBCC clean table help us with this instead of the need of doing the rebuild of the entire table? Let's have a look here. So our table with 5 million records, and let's see how much space this is occupying. And also, we will see based on the index physical stats, which give information, and we can have see the average page space used. Let's then pick this, put it here, so we can do some comparison. Same thing for these ones, but let's put it here. And now let's drop our column. Let's see the space is occupying, again, still the same, no change at all. And let's see what happened on our index. So our in-row data is still the same. Page count still the same. Page use is still the same. Number of records still the same. And the space used is also exactly the same. And now, what about the DBCC clean table? So these are different comments which allow us to run, we can have a batch size, the default is 1000. And what it does in the end, it will be doing a cleanup, but only for the variable linked columns. Meaning that whenever I run this, and if I check what's running, this is a writing operation. So I'm blocking the table and I'm doing something. Meaning that you need to be careful to do not do a bigger size or too big size that will make your table offline and not accessible by the time. However, when we run this, we now can see a couple of different things here. So we don't see anything about the size of the table, so it's still the same. However, here, because we cleaned up space, the average space on in percentage for each page just lower down 30% or 33%. Okay, so it helped to clean up something, but didn't recover like the page and do not compact the page and so on. So yes, you can get some free space, but not the space that you are expecting that you have with the rebuild of a table. And if we check inside one of the pages, we will see. So it's not, after all, this is not the same as rebuilding the table. It's not recommended to do this in a kind of maintenance operations and running over and over. But yeah, here in the end, after we dropped our column, is still here, marked as dropped, but we just cleared the space because it was a var, so a variable linked data type. Moving forward. So now that we know that whenever we drop a column, the space is not freed up right away, maybe it's interesting to find if we have more tables that are in that situation. So they have dropped columns, and we want to know which ones they can be. So let's create a table. Let's create 3 records. Let's drop our date of birth column, and if we check our data pages, just to pick. We just have one in this case. I will pick this one. And here I'm using the dump of the page, but with table results, because I want to show you that we can see here on the records that we have dropped and a null value whenever our column was dropped. So we had the ID, the first name, and here was our date of birth, but now it's dropped and we can see it here. So we could reinvent the wheel, or doing as it could be done in the past, and imagine that you create some temp table, you execute your DVCC page, you put it inside, and if you filter by the drop, you see that for one page on one table, there are 3 records, or for these, which means that there are a dropped column. However, there is a better way to do it, and again, is about using our metadata. So let's insert again the data, and let's see what we have here. So with fewer columns, we can see that we have 3 columns, and we have on our metadata system view, we have a is dropped column, which seems to be what can tell us that we have a dropped column. So I have dropped my column, I did a filter for is dropped, and now I can see that my client table now had a column that was dropped. At this point, if I don't know which column was there before, I no longer know, but is dropped, and that means that some space can be probably reclaimed. So if you want to check 2 more, and to check 2 more than one table, let me create here a second table with a dropped column, and here we can see more dropped columns from different tables. So this is the way that you can run. The note here is that if you are running this on a partition table, it will appear 1 row per partition of that table, okay? Just the way it is, you can, of course, change the query to make it for your needs.
Question for you on that one.
Yeah.
Would rebuilding the clustered index also perform the clear of the dropped column as the rebuilt table?
Yes. Because in this case, the rebuild table was, if I'm not wrong, because I had a heap, not a cluster index. If I had the cluster index, I would need to do the rebuild of the cluster index, or with the same syntax, but in the end, he's doing the same thing.
Perfect. And you're at like 15 minutes left.
Okay. So now that we know how to identify, we know what happens when we drop a column, how to identify them, it would be cool if we could estimate, have an idea on how much space we could get back if I need to rebuild that table. Because maybe that will tell me or answer the question, I'm in a rush to do that because I will recover 100 gigabytes, or I don't care because it's just 400 KBs or whatever. So to do that, we need to pick from the previous examples, the code that we had before. We have here our space use as we saw before with the 14 40 KBs of data. And even that we don't have, again, some documentation for these systems views, we can infer some stuff. And here we can see that we have 28 columns on the 2022 version. And we have information like the maximum row length or the max length that we have for a column. So what I did in this case is start doing some math. So I pick some data and I said, well, this is my table. Each one of these columns exists for this amount of rows. They occupy this total number of bytes because is the max length times the number of rows. And in KBs is this, the number of total page that this size can be translated is 25. Meaning that then I can, when I drop a column, I can see my dropped column here, and I can see that my dropped column has 8 bytes, okay? And in this case, we knew that it was a date time. So with that in mind, we can calculate what is our current page count, or we can not calculate, but get our current page count, and that can be something that you can get from your index physical stats, even with the limited definition, because it can be detailed and it will take longer to get more information. And the final math here will be picking that information and say that, okay, we have this column that is dropped, and it has 8 bytes max length. That means 400 KBs, which means 50 page. If the current page count is 180, if we subtract the 50, we'll have 130, which means that if I rebuild my table, I may expect to have something around 1040 instead of 1440. Okay, let's see if this kink works in this case. It rebuilds, let's check, and our table now has 130, so the 50 page less compared with the before one. And again, caveats on these calculations, compression and stuff, because that will be harder to calculate these values. We have 2 more demos. One, the question is, do you really want to rebuild your table, yes or no? Why bothering doing so? What happens so if you take 1 month to rebuild your table because you have that maintenance window, is this bringing any problem? Let's have a look here. Our table, 50,000 records. We have an average of 27 bytes per record here. We will drop the column and check again our average size, and still 27. We have seen this before, so no writing operation. Our records still take 27 bytes. So what happens if I had another 50,000 records? What will be my thing is still 27. But I had 50,000 records with 27 bytes, and now I had 50,000 records with 19 bytes, because it's the 19 plus 8 of the dropped column. Well, it seems that is not what happened. And to show that, let's pick here a page. Let's dump our page. And let's see here, this is one of the beginning records. So ID number 1, it says that I have a dropped column. We already knew that. But if I pick the latest column or the latest page that is a data page here, to grab one of the other IDs. So here, I'm now working with the ID 99883, but look, our reference to our dropped column is still here. So every new page that was added to insert more data on the table need to bring these overheads and to still write and say, well, it's still 8 bytes here because no one rebuilt the table. But if I pick and do an update on one of the columns here, if I go here, it's still there. So what this proves either insert or update records won't write and remove the waste of space that you have inside of your data page. So you actually need to do the rebuild of your table to reclaim this space. Final one, adding and removing columns without rebuilding in the middle. So at some point it will fail. Why? Let's have a look. I have a table with a much better bio size, or not, 7,000 bytes still to write an essay inside. I will insert one record, and I will drop my bio column, which has the 3,500 nchar, meaning 7,000 bytes, and I will add a new one with the 300. It worked. Cool. Now let's see what is my show config here. I have a maximum record of 7080. Okay. So that means that if I add another 700 bytes, it should work. But no, it doesn't. And why? Because adding this column will change the max size of a record for 8214, including the 7 bytes that we have calculated before, with the 4 bytes for the row overhead and the 3 bytes for the null bitmap. And it says, well, no, we cannot, because you cannot have records more than 8060. So if we pick our page, and here, as you can see, we are working just with one data page. What happens here is that we have still our bio column here. And if we go here to the bottom, you can see that our bio column was dropped, 7,000 bytes. Our car column was added without a problem, but because we still have this one, right, adding a second column with another 600 bytes will result in the oversize of the record, meaning that no, we cannot do it. So, and you can see here that in your metadata, your column is still here being dropped. And we were able to add another one that has 600 bytes, but sure, if I try to another one, 7,000 plus 1,200 will be 8,200, meaning that it will surpass the values. So if I rebuild my table, I can now see that my dropped column just went away. And adding the second column with the uncard 300 won't fail anymore, because now I have space for it. There is a but, and this one is about, here we have like the same table, or almost exactly the same table, but our variable length column is the end of the table, not before the date as it was on the previous one. And in this case, it seems that SQL Server can rely on the amount of data that was there to overwrite somehow and put it there. So here we see that I have dropped the column. I will add my 300, the first column, it succeeds. And this one that failed before, because I haven't rebuilt my table, if I now add it, it still succeeds. And if we see here, the other one just disappeared, and in this case, without the rebuild. So if we check inside of our page, we will see that there is here some data on our, but also here the new one inserted. So the column is still marked as being dropped, okay? The other two are news and they are without physical size because they were added as a metadata. But this one disappeared from the metadata, and this one I don't know like what the engine is doing in the end. My assumption is that he's picking on these two, and because we dropped that and the data type is the same, he can overwrite already because he's on the end of the page, let's say. So if I insert a new record here where I have my new column and new column 2, and I check my page again, just to show that we have here the initial data, and somewhere here we now have our, sorry, I need to pick the second page, not the first one, to show that in this case, you can see here the hello, I'm Alex, and then in the middle, you see hello, I'm Alex 2, which is based on the new column, and at some point we see garbage. So these are like used to be overwrite in the end. And if you go down here, we can see that we have our value with the 600 length and our other value with 600 length. And that's it. Hope that you enjoyed. I know, Jess, if we still have time for questions or not, then I can take it offline.
I was going to say, yeah, we've got about 5 more minutes for questions, but I think everyone's mind is melted. We've got no questions on the last couple. Just a lot of people in awe at your your presentation style and the stuff you've shared. We've been loving it.
Oh, so hope that we all learned something. I learned a lot during this session. A lot.
So that's my
When
question.
I asked you earlier, did you have any demos for your session? You said a couple. That was fantastic.
Let me say this way. If I had enough time, or more time, I had enough. I had more demos to do. I have another 3 demos that people can do as homework to double check something, right? That is my problem with doing sessions, is that I like to share a lot of demos and I have a hard time to select which one should I show.
Yeah, I think when we first talked about what you were going to show, I was like, Claudio, this is way too much. But yeah, there's so many good demos. And like you said, the homework ones are just as good. So we've got one question from Jeff about compression. You mentioned that compression changes some things. Can you highlight any of the major gotchas for how that affects some of the stuff we saw today?
Yeah, so the compression. So the data that is saved on the data page will be already compressed whenever you say that you want to have either row or page compression. What I can show, you see, Andrew, this is useful. About the compression is that we have, so the question would be, we will have the 8060 bytes before or after the compression. So the easy answer is your record uncompressed needs to be no longer than 8060. Then the compression will be applied. Okay, so that is the one. So doing the calculation with compression is difficult because depending on the data that you have inside, the data types that you have, how repeatable the things are, applying the compression algorithm can give you different results, right? Different values. I did the test of getting how much space I expect to get back from a dropped column on a compressed table. And at some point I had, well, you will get minus something because that calculation was not working as not as it should, but you cannot rely on the max size of that column whenever the compression is applied, because most probably it can be less than that. So I would say you can jump here to the data compression information and get some and run on your pace this demo to show that you can only have 8060 bytes of uncompressed data and the compression only be applied afterwards. So if you want to go back from data compression to none to known compression, the record needs to fit inside of one page.
Nice. One other question we had was whether these demos are available for download from anywhere.
Yeah, I will share on the Slack channel my GitHub, but I think later 8KB should also update to the central 8KB GitHub. Is that correct? Nice.
Yes.
Perfect.
So thank you.
Yep.
Yeah, I would just
Thanks,
wrap.
Claudio.
Thank you. Thank you, Jess, for moderating, and let's see more content.
Are we
Yeah,
getting more
great
questions?
job. We
Sorry?
do have a couple more questions.
We've got some time, so
All right, Claudio,
Okay.
here's one more for you at least. Would a reorg work in order to reclaim the space, or do you need to do a rebuild on the table?
Sorry, can you repeat the first part?
Yeah, would a reorg work in order to reclaim the
Ah.
space, or do you need to rebuild on the table? I presume
No,
this is
you
for the
need,
dropped column stuff.
I didn't test that, but it's need a rebuild because a reorg will just move records inside of the same page, meaning that the space that is there will be moved along still. So won't like the most close to that will be the DBCC clean page the clean table that we saw, but with the big gotcha that is just for variable length data types. So yeah, won't do that.
Perfect. And then are there any caveats with data encryption? Not exactly sure the context of that one, but
I'm not sure. So data encryption. I'm not sure. I haven't tested that on with data encryption. I don't know if data encryption will enforce a writing operation on these situations. Something to be tested. I don't know the answer to that.
Yep, no problem.
Also here you can get a bunch of other resources that I found along the way, and some blog posts I wrote about, especially from the drop part of it. And I had here some kind of helpers from Paul Randall, so which show us about the DBCC page, and also this is a big one. I like this post about the anatomy of the page, which shows for the header what each one of these things means, and with that you can have a little bit more information about it. So this is just a copy from the blog post from this source, but can be useful.
This might be one of the most well-prepared sessions I've ever seen, Claudio. Nice work, sir.
Thank you. Thank you. Yeah.
how's everybody's heads doing?
Not good.
All right.
Melted. Yeah, that was really cool.